Hello and welcome to another creative coding video. Today's another in our series of back to basic videos where we go back to very simple ideas and very simple code and practice it so we can develop comfort and confidence and build ourselves a solid foundation on which we can learn new things. We're actually going to be introducing a new concept today, which is drawing curves. So if I'm correct, up to this point we've only ever drawn things like lines, circles, triangles, rectangles, that sort of thing, but not curves. So this is a great opportunity to introduce that as well. So let's dive in. And by the way, what you're looking at on the screen is the example that we'll be developing. Now it might look complicated, but actually it's very little code needed to do that. So it's one of those things where there's a lot of thought and planning gone into a little bit of code, which has a fairly big effect. And for me, that's that's always what good algorithmic art is about. So I think the first thing to say about curves is there are many different mathematical ways of describing curves, and curves can be all sorts of shapes like that. Now, each different application, each different programming language will have their own, one or many ways of describing and drawing curves. For simplicity, we're going to use the one that's built into the P5JS library that we always use. You can always look up the mathematical details of how it's done. We won't do that here because we want to keep this video kind of simple. We'll only learn just enough for us to be able to effectively use these curves. So let's do that now. And there isn't a lot you need to know. So the idea is that we define kind of control points, perhaps like this. And between these points, the P5JS will try and fit a curve, and it might, I'll just change colour so we can see what's happening there, and it might go something like that. Something like that. Now that makes intuitive sense where each of these points that we've defined sits on the curve. As it happens, the first and last points aren't actually used to connect the curve, so the curve in P5JS starts here, but that's okay, that's a small detail. In other systems you might have seen things where you define some points, but you also define kind of arrows or vectors which show you how a curve approaches those points, and this one might be like this, so it has to go bend round to touch that. Let me do that in a different colour so you can see that. If that arrow was perhaps like this, this would have to bend around even more to approach that. There's different ways of doing it, but the point to remember here is that P5JS has a fairly simple, intuitive method for doing it, and it's perfectly fine in many scenarios. So let's just practice doing that. Let's just create some points like this and connect and draw a curve, and get P5JS to draw a curve for us. So let's do that. So I've started off with a blank sketch as usual. I've set up the simple instruction to enable the simple kind of library that we've developed, which kind of helps us to kind of write code more easily and takes away some of the kind of setup for us. So make sure that's enabled. I've just turned up the text size so everyone can see what we're typing. And the way the curves are drawn is by using something called a curve vertex for each point. So the X and the Y position would be there. So let's just say we're moving along the screen, say 100 across and maybe 300 down, and then if I just copy and paste that so I don't have to keep typing it in, then 200, then 300, 400, 500, 600, and I'll do one more at 700 across. And now I need to change where they are vertically, so I might be 200, 300, 400, 500, 300, 200. So these are just some points on that canvas, and curve vertex is saying that that's the point that pins the curve down. We just need to do something a little bit extra around these curve vertex instructions, and we say begin shape to tell it to start drawing the curve, and then end shape to say that we've now finished. So you can take all those points and then draw the curve. So that's fairly simple. It looks like a lot of code, but it's simple. Begin shape, end shape. Just add a bit of a space there so you can see it more clearly. And here are just the points that define the points where the curve is going to travel through. So if I run this, I should see a curve. Kind of do. Yeah, there is a curve there. It's the fill is on, so I can turn off the fill by saying no fill, no fill, and I can perhaps just change, just for effect, some of the just make those points a bit more variable, just as there you go, changing the positions. So that's a curve. So you can see how the first and last points aren't included, but all the other ones are there. So this is the actually, if I draw little circles if I draw little circles at those points just to make it more clear. So if I say circle 100, so if I actually copy and paste that, I'll make it easier to see that. So circle, this is just to highlight the control points. You wouldn't do this normally unless you can really use part of your design. There, so you can see the first and the last points aren't included on the curve, but the curve does go through every other point. So that's nice and intuitive. It's a lot less for us to think about mathematically. We just think in terms of what points do we want our curve to go through, and that's a nice decision, I think. The other methods of drawing curves are a little bit more complicated in terms of the work we need to do. Great, so now that we've got that done, let's actually start using curves. So let's plan an idea. So what I'm going to do is I'm going to use some of the ideas that we developed earlier around moving around a circle. So if this is my center of the canvas, I'm going to imagine a sort of a circle that kind of goes around. This is just imaginary. And what I'm going to do is I'm going to, if I pick a different color, I'm going to pick a random angle, let's say it's there, and I'm going to move around this circle and plonk down a point. I'm going to go in regular steps, but actually instead of those points always being the same distance from the center, I'm actually going to vary it. So what I'll do if I choose a different color is I'll say actually, yep, start there, but then add or subtract a bit of a random distance. So I might start here as one point, I might be over here at that point, I might be over here at that point, I might be up here, might be there, might be there, might be there, might be there. And what that'll mean in terms of a curve is it should be something that varies, still goes around in a circle. Can you see how that works? The idea is quite simple, isn't it? It's not complicated at all. But it's a way for us to draw some really interesting curves that go around, but not as an exact circle. And if we do this repeatedly, if we then perhaps pick a different colour and draw something that's starts at another slightly random distance you know, the distance, this might be say 250 or 200 or whatever it is, and then perturbs it a little bit, so it might be here, and this one might be here, this one might be here, so we might end up going like that. And then if I do another one, and we can do lots of these, this one might end up here. Something like that. It might not end up as a closed loop. We'll have to think about whether we want to do that. But if we draw lots of these, I think it'll create an interesting design. So that's the core idea that we're going to do today. We're just going to go around in a circle, but actually we're going to perturb ourselves a little bit by shifting away from that perfect circle, and we're just going to create curves that follow those perturbed points like that. So let's try that. We'll do it step by step, so don't worry, you know, if this looks complicated. Great, so let's clear all that up. We'll keep the no fill because we don't want to fill the circles. So the first thing we want to do is to move around the circle, and we should pick a start angle. So var start angle. So don't want to always start at this. We could start at the same point, but just adds a bit of variability. So start angle, if I can type, start angle equals random number from say -200 to 200 degrees. So just for those who are new to this, when we use simple, it sets up a lot of the things in the background so we don't have to worry about it, and it makes things simple, particularly for beginners like ourselves, or at least people like me. So one of the things simple does, amongst many things, is defaults to using degrees for angles, whereas if we didn't use simple, it would be radians, and you know, it isn't the most friendly thing for newcomers. So this is saying from -200 up to 200, and then we're going to move around that circle by adding to it in steps. So we can say this is a loop, so if you're not familiar with loops, do go back to the video that introduces them. So we're going to start our angle at the start angle, so it starts at the number we chose, start angle, and as we're going to go around in a circle, so we're going to say as long as the angle is less than or equal to 360 plus the start angle, so whatever that was, plus 360. So that's a full circle around from there. And every time we go around the loop, we're going to be adding angle plus equals a number. Now what number should we add? We could say 5 or 10. We could just turn into a variable, a step. So we need to pick a step size. So let's say var step, so we can adjust it later without thinking too much. So let's say 45 degrees for now. Right, so now that we're moving around in a circle, we need to work out the x and y coordinates. Let me explain that with a picture. So if that's our origin, and as we go around the circle, we need to pick a point, and that point is going to be a certain radius away and at a certain angle. But we need to use x and y coordinates, and again, do go back to the earlier video that introduces these concepts, this trigonometry. But the answer we arrive at is the x coordinate, the x distance, is r times cos the angle, and the vertical distance is r times sine the angle. So that's you know, you can either just remember that because it's so useful, it comes up so often, or you can kind of learn a bit about it in terms of looking up the mathematical history of that. But honestly, you don't need to if you don't want to. It's just something that's worth learning by heart, actually, that turning polar coordinates, as they're called, distance and angle, into xy coordinates always uses this kind of formula. It's just used so often that you probably don't even need to make an effort to learn it. It'll just burn itself into your brain. So let's do that. We'll say, for now, let's just say the radius is, I don't know, 200, just for now. We'll kind of refine that later. So we're saying x equals radius times cosine of the angle. There you go. And we're saying var y equals radius times the sine of the angle. And then what we're going to draw, just for now, is just draw a circle at that point, x, y, size 5 or 10. And just to convert it to our canvas, because we're working from the centre as it were, we'll say x is 300 plus, or is it 400 plus, isn't it? And then 300 minus, because y goes in the downward direction. So this is something that we do often in our sketches, and again, to kind of go back to the earlier videos to kind of explore why. It's just one of the quirks of P5GS, which actually I don't like, which is the coordinate start in the top left, and x goes across and y goes down, which is a little bit of an interesting choice. It'd be nice if they allowed that to be changeable. That would be really handy, perhaps in a future version. Anyway, so if we do this, we should get circles going around a circle of radius 200 with no kind of randomness in at all. This is just to check our work as we go along. So let's do that. Let's run that. Great. Yep, we can see that. We can see wherever the random starting point was, and I don't know which one that was. We've got the points drawn around the circle, and the increase in angle is 45 degrees. If we did say 5 degrees, we'd get more closely spaced circles. There you go. So we've done this kind of thing before, actually, so none of this should be that particularly new. We're just practicing it. Now the magic bit, we're going to actually randomize that. We're going to perturb, we're going to jiggle that radius. So we'll start off with 200, and then we'll add some randomness to it. So random number, let's say, I don't know, minus 10, or let's say minus 50 to 50. That might be too big, so we're adding to it a number that goes from minus 20 to 20, just a random number. And if I make that 5 again, we'll see the effect more clearly. So we should see these circles going around these dots, but jiggled a little bit. There you go. Can you see how it's jiggled a little bit? If we run it again, we should be a little bit different. Yep. Fantastic. Great. So these will be the points. They'll be invisible, but they'll be the points through which a curve runs. So let's go back to make them 45. And instead of drawing a circle, we're going to say curve vertex to tell it we want our curve to go through this point. Now, where do we put our begin shape and end shape? Well, we're using this loop, this one here, to draw all these points, or to mark them. So we need to say begin shape before it, begin shape, and then end shape goes after here, end shape. This way we should see a wibbly curve going around in a kind of circular shape. So let's try that. Kind of, yeah. If you run it again, we see that. Let's make those divisions smaller again. So the step size, the angle step is 5. There. That's much more kind of obvious now, isn't it? So that's achieved what we wanted, which is a kind of a curve going around a circle, but wiggling around that kind of smooth, correct circular orbit. So we're almost there. What we now want to do is draw lots of them. So to draw lots of these curves, we need to repeat the code with a loop. So let's think about which bit of the code we're going to loop. Which bit are we going to repeat? Well, we're certainly going to repeat the begin shape to end shape code, all this code here, because that's the bit that starts the curve, defines the points it goes through, and then ends the curve. Do we want to include this in the loop as well? Well, we do, because we want the curves, all of them, to start at a different point. So we can say var, let's call the counter I, for example, just keep it simple. I is less than, let's say 20, and we'll increase that by 1. So we're going to draw 20, 0 to 19 curves, and then we'll just put the end of that loop here, which means everything inside I'm going to indent a little bit just to show that it's part of that outer loop. So I'll just put a comment here saying lots of curves. If we run that, we should now have lots of those curves. Let's try it. Oh, I missed something out. Oh, right, that should be a 4. Okay, so we've certainly got lots of those curves. They're a little bit dense, so let's think about perhaps changing some of the colours and maybe the thickness as well. So one thing I could do is to say, make them thinner, stroke weight. So the default is 2. Let's see what happens if we do 1. Yeah, that's interesting. I mean, we could stop here. This is an interesting kind of design as it is. This is an interesting pattern. And again, what we've done is we've done a lot of thinking about how we construct this design. There's not a lot of code. I mean, look at it. That's all there is. It all kind of fits into one screen. And it's nicely spaced out as well. But the idea was important, which is we move around a circle, placing down points through which a curve will go, and then actually we'd perturb it a little bit with a little bit of randomness, and that creates an interesting design. Let's keep going in terms of stylizing it. When we've had lots of things going on a screen, lots of kind of shapes or content, by using translucency it allows us to see more of the design. So we can say stroke. What stroke shall we do? 200, 0, 0, 100. So that's a kind of red, but sort of see-through as well. Let's see that effect. It's a little easier to see now, isn't it? Let's make that even more translucent. There you go. Which means we can keep layering more on. But I'm going to go in the other direction. Instead of actually having more and more of these things, I'm going to thicken the line and try to create an interesting effect where, let's draw a sketch to see what I'm going to talk about. What I'm thinking about doing is having a thick line, a thick kind of curve like this, which I can colour in. I should have chosen a thicker brush, but you get the idea. And then inside that, do a thinner stroke. Actually, let's illustrate that really by doing that with a thicker curve. So if I have a curve that goes, and then if I have a thinner curve that covers exactly the same, if we draw lots of these over each other, that might create an interesting kind of effect. So I'm going to try that now. So to do that, I need to draw each of these curves twice. So this, from begin shape to end shape, is a curve, but I need to draw it twice. First thick, and then thin in a different colours. So let's do that. Let's pick a loop for var counter, let's call it p equals 0. P is less than 2, which means it goes from 0 to 1. I'll just indent that code again so again we can see what we're doing. And I'll just write a little comment to remind myself later why we did this. So thick and thin curve. So that means inside here we need to somehow set the stroke. So how do we do that? We can say stroke weight, and we need in here some mathematical expression that flips between the thin and the thick weight based on the value of p. So we can say it's, if we say 1 minus p, that means the first time it's 1, the second time it's 0. We don't want it 0. So we can have a minimum thickness, so we can say 2 plus 1 minus p. So we'll start off with 2 plus 1, which is 3, and then the second time it'll be 2 plus 0, so 3 and 2. Let's give that a go. In fact, we can make that even more exaggerated by multiplying that by 4. What that does is, when p is 0, 2 plus 4 will be 6, and when p is 1, the second time we go over that same curve, it'll just be 2, because 4 times 0 is 0, so it'll be 6 and 2, so there'll be a nice kind of contrast there. So we need to change the colours as well and then we'll do the same thing again. The colour will depend on p, because in one case we want it to be a lighter or darker colour, and we want it to be different the second time. It's easier to see it done than talk about it. So stroke is the command, as we know, that sets the colour. We have red, green, blue, and we can just pick something based on p. I don't know, let's say 100 times p, and here we might say 200 times p. So when p is 0, that'll just be 50, 0, 0, 50, and when p is 1, it'll be 200, 150. Let's try that. What did we do wrong? They're not going over each other, are they? Let's draw fewer of those lines and give them a bigger step, just so we can see what's going on. Actually, let's try that with just a bigger step. They don't seem to be going over each other, do they? Let's just draw 10 of these curves. Yeah, that's obviously, yeah, so they're not going over each other. Let's kind of increase that kind of variation in randomness so we can separate out the curves a little bit more. So instead of perturbing it by plus or minus 200, some random number in between there, we can say 100 times, oh no, we don't need that, we can just say minus 200, 200, oh, that'll be quite a variation. But it should pull out the curves. Oh, that's quite a lot, isn't it? Let's do 100. Right, they're definitely not going over each other, so we have a logic fault, a logic bug. We've made some mistake in our reasoning. You know, we wanted the orange lines to go over the same, points so that they would overlap the thick line. And the error is the fact that the variation is a random number. What does that mean? It means for the thick line we'll have a random radius, distance from the center, and then for the thin line you'll have a completely different random variation from that radius. Let's say that in pictures. If that's our radius of 200 and we were wanting to perturb away from it, we're using randomness to move either further away, like in that direction, or closer. Now, when we do a second curve, there's no guarantee that the point that the curve vertex will be the same as the first curve. In fact, it's extremely unlikely because these are randomly chosen. So if you recall, we have a solution to this. We previously used this idea of noise rather than pure randomness. Now, noise depended on a variable, we can call it x or r, which meant that if we did noise depending on x, if x is always the same, then noise is always the same value. So that's nice, because if we say noise based on the angle, it'll always give us the same value. It'll still look random because that's the whole point of noise, but it means that we can have that predictability. Again, do go back to that earlier video. There's a few actually, but there's one that really introduces the concept of noise. It's a really powerful, really amazing idea. It's used so much in algorithmic art. I really recommend you go and have a look at that. I mean, it's come up again, it's useful again, and it's useful so often. I really can't kind of impress upon you, the importance of it. So instead of random number, we're going to say noise based on angle, and then we can fiddle with scaling. So if you've done the previous tutorials, you know that we have to get the angle scaled, or the parameters scaled right. So if I, let's say 10, just so that it doesn't change so much, because remember it's going into the hundreds, the angle, so we're going to divide that by 10, and because noise goes from 0 to 1, I'm going to multiply it by 2, so it goes from 0 to 2, then subtract 1, so it goes from -1 to +1. I wish it did it by itself. And then we can scale this by saying 100 times. If we do that, we should have those lines overlap each other now. Let's try it. There you go, that worked. Can you see? Let's make some of those lines a bit thicker so we can see more clearly. Let's say that's 8, and I'll change the colours so it's lighter a little bit. Let's say 50 plus, just add more light into the red, and same here into the green. Let's see the effect of that. There you go. You can see now, yes, it is random, but because it's based on noise, which takes a parameter, we can make sure the curves overlap, and that's kind of nice spaghetti kind of ribbon shape. And then we can go back to having lots of them. Let's say we want 20 of those, and I make them thin again, not as thick as that anyway. Let's try that. Great. So that looks like spaghetti in a bowl. And as you do these things, you should always kind of experiment and play. So you might say, let's not scale the angle down. Maybe that'll create more variation. Or if we do scale the angle down by say 1000, that should create less variation. Almost perfect circles there. You can experiment with the size of that circle, so you can say, I don't know, 100, so it's smaller. There you go. You get a blob of spaghetti. It's rather effective actually. Looks quite realistic. That's quite comical. I like that. So we could stop there again. You know, we've done quite a lot, but I'm going to introduce one more idea, and it's another one that comes in often, comes in helpful, and I'll explain the idea. So the idea is that instead of just layering on lots and lots of these curves, what we do is we draw one, and then we draw a rectangle over the entire canvas that's see-through. So it kind of covers it as in a kind of thin colour that's see-through. Then we draw the next one, and then we do it again. We colour it, colour the rectangle, colour the canvas, cover it with a see-through rectangle, and then we do it again. And in this way, we get a sense of depth, where each layer, you know, it kind of gets darker and darker. So if we have a light kind of coloured film, as it were, that we put over the canvas, it means that the ones that we draw initially will be lighter and the later ones will be darker. And you can do it the other way around, you know, you can make it dark to light or light to dark. So we have that sort of effect. Can you see there? So let's do that. So what I'm going to do is I'm going to set a background in the setup section that's lighter than what we have at the moment. If you want to see the effect. Oh, it's not as light, is it? Darker, I meant. I think the default is 151 as a grey value. I need to look that up. So it's slightly darker. And what we're going to do is, as we draw these curves, the 20 curves, I'll put a comment, we'll say overlay canvas with see-through rectangle. So I'll draw a rectangle and it'll go from the top left to the bottom right, but its colour needs to be see-through. Let's say 150, 150. So this is grey and see-through, very see-through, so a low value for the translucency. I don't want it to have a edge, so I need to say no stroke, but because we are using a stroke for the curves, I'll need to add that again afterwards. In fact, I set a stroke here, don't I? Yep, so I don't need to undo that. I'm going to fill it, so we need to say no fill, because we don't want those curves to have a fill. That was up there, so I can delete that. Don't need stroke weight either. Do I? No, because we set those, don't we? We don't need any of those because we set them later. Let's see what effect that has. So what we're doing here is we're drawing a see-through rectangle over the entire canvas after each of those curves. There you go. So you can see the ones in the background are much more pale because we've essentially put a very light grey film over them, and the ones that are drawn most recently are fully contrasty, as it were, much clearer. So it creates a depth, a kind of a fog or a depth effect. So that's quite nice. Another little tweak to this is something called a blend mode, which tells you how things appear as you layer colours over each other. And you can play with these, but and you should certainly look it up on the website, you know, the different options. But the blend mode multiply, I mean, it's the one I'm going to use. It kind of multiplies the colours and makes them more kind of contrasty and kind of harder, as it were. If you're familiar with Photoshop and some of the other image editing kind of tools, you'll have seen this where different layers can blend into lower layers in different ways. So you can say the lightest colours come through, or the darkest, or multiplying all the RGB values will kind of sharpen things up or lighten things up. So you can experiment there, and then I'm going to reset the blend mode, and the default is just called blend. Again, you should look these up on the reference website. I'll show you how to do that in case you're not familiar. Go to Google, type P5JS. If I type it into the search box, P5JS, and I type, I don't know, blend mode, I should get taken to the reference page. And there you can see some examples there. And here are some of the options. So you should never be shy of exploring the P5 reference. So let's see the effect that has. There, this is what I really wanted. Something that's a lot more kind of, clear and not really fading into the background. So instead of going paler, they're actually going darker. Nice. Yeah, so I think I will stop there, because this was a kind of a back to basics video, and the idea really was just to introduce this idea of curves and just to show how we can use them in really kind of interesting ways. We've had, we'll just recap the idea. We introduced curves and the intuitive idea of defining points through which they pass. So that was nice and easy. We revised, revisited the idea of moving around a circle using sine and cosine, those expressions that we keep seeing everywhere, to convert from radius and angle into x and y, perturbing it a little bit using either randomness or in our case noise, because it helps us. And we drew essentially spaghetti shapes, and then because we used two, a thin one and a thick one, we drew over a thick curve and then a thin curve to have a kind of a nice kind of effect like that. It almost gives it a 3D feel because it sets it in relief, as it were. And that's it really, and we used a bit of colour that depended on that variable which decided where it was the thick and thin. And as I say, you can experiment yourselves with making it thicker and thinner and trying different colours. I mean, that's too thick. It's a different effect. It looks more like a road network. Yeah, so I'll stop there. Have a go yourselves. The idea is to practice and experiment. Play with things yourselves, like the step size, maybe 15 here, to make them even more wiggly like that. I quite like these. These look like nests to me in a way. They're just little simple designs like that. Great, I'll stop there. Make sure you can play and experiment. You'll see the link to the code that I've done. And I hope you enjoy that. See you next time. Bye.